So because we need initial energy of the circuit also. With the slab, the capacitance is 4C. When you pull out the slab, how much the capacitance will decrease by half, no? Then it will become 2C. It will be understood like this. Capacitance is 4C with the slab. It's understood. So need not to mention also separately. So first we'll calculate the charges here. Q naught should be equal to C into E. And the charge Q1 should be equal to 4C into E. The initial charge, so initial energy of the circuit, Q naught square by 2C, Q1 square by 2C, or directly you can write C into E square, C1 into E square, C2 into E square. So instead of these charges, no, let me go for directly, we know potential, no, C E square by 2. What is the capacitance of this? 4C E square by 2. So this will be 2, 5 C E square by 2. Now what I do, X agent will pull out this capacitor, will pull out the slab from the plates of capacitor. So this slab now, when it comes outside, so what will happen to the capacitance of that? Shall I write 2C now? No longer it will be C, no? It should be 2C. Why? Because when you insert a slab, the capacitance will increase K times. When you take out a slab, the capacitance will decrease by 2 times. Decrease by K times. So here K equal 2, no? So I'll write 2C. This one I'll remove it. Charge Q1, that confusion. What will happen to charge in this capacitor? This one of the cap will remain same. The charge here is going to change. Any reason for that? Because capacitance change directly connected to parallel to the cell. So again the charge Q0 C as it is. Q2 should be equal to 2C. So what is the final energy of circuit? Should be C square by 2, 2C E square by 2, 3C E square by 2. How to bring the idea of the heat generated. X agent also does work, no? How to bring the work done by X agent. So when it's pulling out the slab, why the X agent should do work? Next question comes. When it's pulling out the slab, the capacitor will exert attractive force on the slab. So the X agent weapon should do work to overcome that attractive force. Previous class we discussed here. That's why he has to spend energy. So how to calculate that work done by X agent? And also the role of the cell. Cell is also there. So there can be possibility of any charge can flow through the cell. No? How do we can say? So here the charge of this capacitor, you see Q naught and minus Q naught plus Q naught minus. The charge of this capacitor has not changed. Keep as it is. Look at the Q1. Q1 was how much? 4C. Now it is Q2 is 2C. So some charge left the capacitor. No? And this charge left will flow like this. You have to trace out the charge here. So the charge will flow through the circuit in this way. So and here, so the cell, it consumes energy, no? The cell, what it does? Negative work or consumes. So work done by the cell will be, in fact, negative here. It will accept energy. What was our question asked? Heat generated has to be half here. So how to bring that work done by X agent in pulling the slab? So as I told you, work done by X agent should be equal to change in potential of the capacitor. Now earlier there was only one capacitor. What about here? Two capacitors are there. So only change in potential of the capacitor across which is pulling out the slab, not the total capacitance of system. There's a condition which we have to follow here. So only what happens? The change in capacitance of the change in potential of this capacitor as to where the slab is kept, that should be equal to work done by X agent. So here I'll write down work done by X agent should be equal to mod of delta U of what? So we'll call this capacitor, second capacitor, or capacitor. We'll give name A and B. Because 1, 2 again will be confusion. This is it should be only B, not of total system. So this should be final, like a final energy is how much? 3c e square by 2. 5c e square by 2. Why I'm taking mod? Whether energy across capacitor increases or decreases. The change in potential energy across the capacitor is what? Work done by external agent. So this should be equal to C E square. In fact, it's a negative because of mod. This much of work is done by the external agent to pull out the slab. He has given that energy to the circuit. So let's write now the equation for this one. Again, the same basic equation. Initial energy plus work done by external agent, work done by cell equal to final potential of system plus heat generated. There's a basic format you do remember whenever anything work done, energy comes, no? There's one basic format. So initial energy, we know it. Work done by cell will calculate. What is work done by the cell? Minus Q into E. So what is the value of Q should be equal to CE. Q is equal to Q1 minus Q2 or Q1 minus Q equal to Q2. So this Q equal to 2C. Why negative? Anybody here why negative we took? It has left the positive plate, no, of the capacitor. It has left the positive plate of the capacitor. Positive charge enters positive terminal. The positive charge here enters, no. So cell does negative work. Okay, got this one? Yeah.
Work done by external agent is change in potential energy of capacitor B.
Yeah.
But you wrote for the total thing.
Oh, symbol what I wrote, 5c square. Only of that is how much? 2c square, c square. I think only, yeah, this one. What was the final energy of this? C square. Yeah, we'll make it. I'll make changes. Thank you. That is how much. This is of capacitor B, no? I'll write it nearby this. It'll be easy for us. Check it now.
Sir,
Will be C square only. Okay, this Q equal to, so,
how did you trace out the charge flowing direction of the charge, sir?
bucket concept. There was a charge Q1. The positive charge left the plate here. So minus Q. And finally it has become Q2. Okay.
Yes, sir.
There's a basic idea. Okay, Q equal to, we got this much. So Q is equal to how much? 2CE. I'll write it. Okay, I think we did everything order, no? Only of plate B, what was the final charge? 2C square by 2. As it is, I'll write 4C square by 2. Yeah, fine. So this will be 2C square. Negative sign, you bring it. Why negative sign? Positive charge. Substitute all this, you'll get the heat generated. So let's go for the calculation part.
0.
You're getting 0. Huh? Yeah. Initial energy 5. Work done by external agent. C square. Work done by the cell minus final potential energy 3CE. Got this? So no heat is generated. These are the some types of numericals. So that tracing out charge, again say there's only one method. You take any one plate of capacitor, compare initial final. With that, you can say charge left or enter the capacitor. Then if any junction comes, apply like a conservation of charge. Like that, in every branch, you have to trace out the charge. Since here, plus Q naught, the charge on capacitor didn't change. It was a little bit easy. If charge on capacitor A also changes, then you apply the conservation of charge principle and analyze it. Fine. So these are some idea I'm giving it. You have to work out still more better numericals based on this.